Okay, this short video is going to be just on balancing equations, and particularly these combustion equations. I've already posted these on Canvas, but let's go and do this example. Here's a very straightforward one. We have C2H6 plus O2 forming CO2 and water, H2O. There's the chemical equation, and to balance a chemical equation, you usually need to be given the actual reaction that's going on here, and this is the reaction that's going on. The reactants are on the left, the products are on the right, and with these hydrocarbons, like C6H6, C2H6 is a hydrocarbon, I have suggested you do them in the order of carbon first, hydrogen second, and the oxygen last. And so I'm writing those three elements on the reactant side and the product side of this equation. Those are the only three elements represented. And every element that's represented in the reactants will be represented in the products. If that's not the case, the chemical equation, there's something wrong with it. You can't have carbon on the reactant side and no carbon on the product side. That won't happen in any chemical reaction. So what we have in C2H6 is we have two carbons. So to get two carbons to come out in the products, I'm going to put a 2 in front of the CO2. What we have in C2H6 is 6 hydrogens. And to have those 6 hydrogens appear on the product side, conservation of mass requires this. I'm going to put a 3 in front of the H2O. 3 H2Os contain 6 hydrogens, or 3 times 2. We've got 6 hydrogens. Okay, now we go that far. We get the carbon and the hydrogen balanced, and you can see that oxygen is coming out of this reaction, resulting in this reaction as CO2 and H2O. So this has 4 oxygens in it, and there's only 1 oxygen in every H2O, and there are 3 H2O molecules. So we have 3 oxygens coming out there for a total of 7. Now that's a little frustrating because oxygens come as O2s. And we have an odd number of oxygens. So we need to balance our oxygen over here. And to get 7 oxygens, we would need 3 1/2 O2 molecules. 3 1/2 times 2 is 7. And technically we are balanced. We are balanced. But we do not like fractions in these coefficients. So what you can do here is multiply every coefficient. In other words, double the reaction. Double the reaction, as I said in class, just relating it to a simple pancake recipe. If you have a recipe for pancakes and you have 4 ingredients going in there, and it only makes 12 pancakes, but you like 24 pancakes, you have to double every ingredient. That's what doubling the recipe means. You double the number of eggs, you double the amount of flour, you double the amount of oil and milk, etc., and you will get double the amount of pancakes. And that's the same here. You can't just double one thing. 2 times 3 1/2 is 7. That gets us our our integer. 2 times, there is a coefficient here of 1. So 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. So we end up with this final equation. All right, and you got to be like a banker. Bankers double check everything. So let's just double check right now. We'll go with our CHO. Carbon, 2 times 2 over here gives me 4 carbons. And on the other side I have 4 CO2s. C2H6, 2 of them, 2 times 6 is 12 hydrogens. And 6 times 2 over here is 12 hydrogens. 7 times 2, I've got 14 oxygens over here. Let's see how many oxygens we have coming out in the product. 4 times 2, there's 2 oxygens in every CO2. That's going to be 8 oxygens. 6 times 1 is 6 for 14 oxygens. And you can see that the amount of everything on the left is equal to the amount on everything on the right, and that's a balanced equation. Okay, I'm not going to do every one of these, but why don't you just pause the video just for a second and do, or a minute, and balance this equation. C6H14 plus oxygen yields CO2 plus water. Okay, pause it. And what you should have gotten is 2, we're going to have to double it again, 19, 12, and 14 to balance that equation. All right? The other ones here, like I said, the balanced ones are in Canvas, but work on these and you can see what they are.